What's poppin', dogs? Mr. Allen here with a video on the greatest theorem of all time. I'm talking Pythagorean Theorem. Pythag for short. We're going to solve for these missing sides in these four different right triangles. Key point there, guys. Got to be right triangles to hit it with some Pythag. So we're going to solve for x in each, give approximate and exact answers for each when applicable, and simplify radicals when possible. Okay. Well, this first one here, I'm looking for my hypotenuse. And let's jot down Pythag real quick. I have a squared plus b squared equals c squared. C has to be my longest side. Doesn't matter which one's which for the two legs. So which one am I looking for here in my triangle? You guys hear Jenny right there? She's hanging out for the math vids. Well, my hypotenuse is x, so that would be my c value. The 4 and the 12 are right here. Okay, it doesn't matter which one's a, which one's b, because they're both the legs, all right? So I've got 4 squared plus 12 squared equals x squared. Well, 4 squared is 16. 12 squared is 144. If you didn't know that, it's okay. You can always bust out your calculator. But some of those squares are going to become, you're going to start committing them to memory, right? You're just going to start remembering those because you see them so often. Then I've got 16 plus 144. Well, that's to be 150, 160 equals x squared. Now, to get my approximate, okay, first off, I'm going to have to square root on both sides. I should really write that down. Square root, square root. Jenny is whining right now. She's trying to, she wants to answer the question, right? We all want to answer the question when it comes to Pythag. So if I square root 160, second x squared on the calculator, okay? And I put in 160, hit enter, I get 12.649 and change. So we'll say x is approximately 12.65. So that's great for my approximate answer, and I rounded it to 2 decimal places. But oftentimes we ask for an exact answer with simplified radicals. So how do we go about doing that? Well, I'm going to do that in a different color here. I'm going to bring the 160 over. And what we have to do here is we have to break it down with prime factors using a factor tree. Okay? So if I break this down to 2 and what is that, 80? And then I do 2 and 40, 2 and 20, 2 and 10, and then I got 2 and 5. Oh my goodness, that was a lot of 2's right there, right? 280, 240, 2 times 20 is 40, 2 times 10 is 20, 2 times 5 is 10, and 5 is 5 and 1. So it's already in prime factors, right? So if I circle this pair here and this pair here, I have 2 pairs of 2's. 2 times 2 is 4. And then I got to put the 2 and the 5 back together, so that would be 2 times 5 is 10. So my exact answer here is 4 root 10. And if you were to type it into your calculator right now, 4 times the square root of 10, I'd get the same exact decimal. You could see it on there if I had it plugged in, but I don't. Simple square roots in the calculator. We should know how to do that, right? It's second x squared, kind of kitty corner from the 7. Take a look at it. Okay, so there we go. Approximate answer, exact answer. A lot of times people think, oh, the decimals, aren't the decimals more exact? No. I rounded my decimal answer, therefore it is no longer exact. I'd have to write down all the decimals I see in my calculator and beyond infinitely, because this one goes on forever, all right? Okay, so those are my 2 answers. If it says exact, reduced radical form. If it says approximate, decimals are cool. All right, if it doesn't say, it's a dealer's choice, but I would check with your teacher before you pick one or the other, all right? Read the directions. It's usually in the directions. I better double check my directions on my quizzes to make sure it's in there. Okay, next one here. Now I have my hypotenuse of 10. I don't have a leg, and I have another leg. So when I set this up, the x can be either my a or my b. Does not matter, right? It's up to you. I'll do the x first. X squared plus 6 squared equals 10 squared. And now I'm going to, do some stuff with my numbers here, evaluate the numbers. 6 squared is 36. 10 squared is 100. And then I'll subtract 36. So I got to do a little algebra here, a little solving. No big deal. We get 64. And then I'll square root on both sides to get x by itself. That's how I undo something squared, is I square root. And square root of 64 is 8. Now, in algebra land, when we square root on both sides, we always have this plus or minus. You may remember that from quadratics. Because we're talking about a length here, we can't have a negative length, so we omit the negative solution. It's what's called an extraneous solution. We're only going to deal with the positives when we're talking about lengths of triangles or areas or anything like that. That needs to be a positive number. We'll omit any kind of negative answers that may occur in algebra land, okay? So I get x equals 8. That is my exact and my, well, just exact, right? There's no rounding necessary, so that's my only answer there. You'll actually find that this is a 6, 8, 10, which is actually double of a 3, 4, 5 triangle. We have some cool Pythagorean triples that you'll learn about later. 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25, to name a few. They all come up. They're nice integer things, integers that fit Pythagorean theorem. So no decimals, no reduced radicals with those. Those are called Pythagorean triples. All right. Video on that later. Next one here. I'm looking for a leg once again. Okay. Looking for a leg once again. Now, I'm going to go with orange for this one. So, let's see what we got. We've got 8 squared, x squared, c squared right there. How about you x squared first, actually? X squared plus 8 squared equals 12 squared. So, we got x squared plus 64 equals 144. I'll subtract 64. I know I'm going to run out of room here. I'm probably getting kind of close. Let me see if I can see it on my watch. Got one more line in this thing. X squared equals, if I subtract 64, what do I get? 80, right? 144 minus 4 is 140. Minus 60 is another 80. Okay, cool. And then I will square root on both sides, okay? So my approximate x is approximately, when I plug in the square root of 80 on here, because it's not a perfect square, I'll get a decimal of 8.944. So 8.94. So that is my approximate x value. But we also want our reduced radical form. I'll do that in green again so it matches up with that one. So I'm going to put my square root of 80. And then I'll start breaking it down. I start with 2s. This is my strategy. I start with 2s. Some people might be like, oh, I'll start with 16 and 10. And actually, that would break it down really quick with this one. But as a more systematic approach, I just start with 2s. And then I'll do 2s until I can't. 2 and 20. 2 and 10, 2 and 5. And I kind of ends the same as that one. It's just double, right? So now what I have is a pair of 2s, a pair of 2s. So I have x equals 2 times 2 is 4, square root 5. Hopefully we got that whole thing in. Hello, Mr. Watch. It's not showing me right now. Hopefully it's there. X equals 4 root 5. I wish it would show up. And just in case it's not, x equals 4 square root 5 is my exact answer. There's my approximate. Okay, cool. One more example, guys. This is a lot. This is a loaded Pythagorean theorem problem. It's exciting stuff. I know. Last one. Whoa, I got a 2 root 3 here, man. What's up with that? Okay. Well, let's identify here. We're looking for my hypotenuse, which is my c value. So these two are my legs. Doesn't matter which one goes where, right? We always identify that first. We were looking for a hypotenuse here. That was my c squared. Here I'm looking for a leg. It's my a or my b squared. Here I was looking for a leg. It's my a or my b squared. Here I'm looking for my hypotenuse. That's my c squared. So this one here will be 6 squared plus, now this is key, 2 root 3 must be in parentheses all together here. I'll tell you why in a sec. Equals x squared. Okay, that 2 root 3 has to be in parentheses. Reason being, when I start squaring things, this is 36 plus the 2 gets squared and the root 3 gets squared. So I really have 2 squared times root 3 squared. I can distribute my exponent into a product. Okay, a 2 times root 3 is a product of two things. And I can individually square them. So I get 4 times, well, square root and squared just cancel. 4 times 3 is 12. So this becomes 12 right here equals x squared. Dope. All right, now I can add those together. I get, 48 equals x squared, and then we'll square root. So I'm going to have my approximate, and we'll have our exact. Let's see where I want to do this. We'll do this. Approximate's going to go right here. So square root of 48, that's 6.928, so 6.93. That is the approximate answer. Now the reduced radical form, I will show that in green. And I'm going to do that right here from the 48 that's existing because I'm going to run out of room otherwise, guys. There's not a ton of room. So I got 3. And let's see here. What is that? Why am I having a brain fart here? 316. There we go. Now you may know, square root of 16 is 4. Okay. So I'm predicting that this answer is going to be 4 root 3. I'll show you why in a sec. Well, we'll see it all break down with the prime factors, but the square root of 16 is 4. That could come out. I can't square root the 2. It stays in. 4 root 2. Keep that in mind, okay? So I'm going to break this down further. 2 and 8. 2 and 4, 2 and 2. Circle my pairs. I got a pair of 2s. Pair of 2s. 2 times 2 is 4. Root 3 is left over. It's the only one left in there. Woo! So if you can, or you spot them, perfect squares, you can just square root that and deal with the leftover. Okay, so nice little way of going about that. That I would say is a little more advanced. Okay, this is the nice systematic approach. Break it all down. Look for my pairs for square roots. Break it all down. Look for my groups of 3 if they're cube roots, and so on and so forth. So nice systematic approach with the prime factors that will be asked of you on most math tests is to simplify radicals when possible. Possibly also giving a decimal approximation. I do that more in my geocon class when we're building stuff, doing math, building stuff, and we need actual measurements that we can read on a tape measure. We go through decimals and all that good stuff. So for mathy math type stuff, though, these are generally my proper answers. All right? There we go. Pythag, baby. Best, greatest, most awesome, dopest theorem of all time. Thank you guys for watching. Have a wonderful day.